Prove that A minus B and C minus D are disjoint if and only if A intersects C is a subset of B union D. I draw here two examples. A minus B is this green one. C minus D, similarly I have the same for C and D, so C minus D is this green part. So we see that two green parts are disjoint. Yep. So the first part here, the two sets are disjoint if and only if the intersection of A intersects C, A intersects C. So A intersects C is the empty set. So the empty set is a subset of any other set. So for example, in this case, it's true. Just have some intuition. So what about the other case? Say A minus B. So I have this set minus B. A minus B. So this is this green part. A minus B. Use the color C minus D. C minus D. They are disjoint, yes. A intersect C. In this case, I want to draw an example so that A intersect C is not the empty set. A intersect C is this red part. A intersect C. This red part. A intersect C is a subset of B union D. So B is here, D is this one, so B union D is this color. So the red one is a subset of the whole B union D. So this is correct. So in other diagram, we still have the correct statement for this one. So now let's prove it. Something we don't have to, and we might not. We don't want to draw all possible diagram, right? A, B, C, D can stay, can be disjoint, can intersect, whatever. But in any case, this statement is true. So let's prove this one. This is by conditional, so we do it to rejection. Suppose that these two sets are disjoint. And we need to show that we have this subset. We need to show that A intersect C is a subset of B union D. Let X be an element of A intersect C. We will show that X is in B union D. So let X in A intersect C. We will show that X in B union D. So we can do it by contradiction again. We will prove it by contradiction. Okay, so assume that. So we need to prove this is true, right? But now by contradiction, we assume that this is not true. So what is true? X not in B union D. X not in B union D, what does this mean? This means X not in B and X not in D. Is that a bit too fast? Why X not in B union D mean this? So maybe recall. X in B union D mean if X in B union D mean X in B or X in D by definition of union. So negation of that x not in B union D mean x not in B or become n x not in D. So that's why I have this. Okay, so what next? Now we have x not in B and x not in D. And remember, we have the hypothesis here, x in A intersects C. Since x in A intersects C, we have x in A and x in C. Okay, so now we have x in A, x not in B, therefore x in A minus B. And x not in B we have x in A minus B. So now another one, we have x in C and x not in D. We have x in C minus D. Okay, x in A minus B, x in C minus D, therefore x is in the intersection of the two. X must be in the intersection of A minus B intersects C minus D. Okay, so say something between them, A minus B and C minus D. But our hypothesis says that the two sets are disjoint. So this contradicts to the fact that they are disjoint. This contradicts to the fact that A minus B is disjoint from C minus D. Therefore, our assumption is wrong. So our assumption here is wrong. This assumption is wrong. Therefore, x must be, so we assume that x not in B union D. This is wrong, so x must be in B union D. So we did x in B union D, and therefore we have this subset. And hence A intersects C is subset of B intersects D. So this is the first part. So forward direction. Now we do the backward direction. Suppose we have this, and we need to group the two sets are disjoint. Backward direction. Suppose that A intersects C is subset of B union D. We need to show that the two sets here are disjoint. Okay, I guess we can do contradiction again. We need to show these two are disjoint. Now assume they are not disjoint. We can prove by contradiction. Assumes that A minus B and C minus D are not disjoint. This means that there must be some element between them. So this means there exists some x in a minus b intersect c minus d. Okay, so x in a minus b and x in c minus d. Okay, we have x is in a minus b and x in c minus d. Okay, now just your definition of z minus, what do we have? We then have x in a and x not in b. We also have x in c and x not in d. Okay, this comes from here. So the first one comes from the first part. The second one, x not in x in c minus d, so x in c and x not in d. Okay, x in a, x also in c, so x in a intersect c. X in a intersect c for the first part. The two implies x in a intersect c. X not in b and x not in d. This means x not in b union d. We say because x in a and x in c, and the other one, since x not in b and x not in b, we have x not in b union d. X not in b union d. I explained that just like a bit ago. So I said that x not in b union d means x not in b and x not in d. This is exactly that. X not in b, x not in d, x in not in b union d. Okay, we have x in a intersect c, but x not in b union d. This is not true, right? This contradicts to this hypothesis. So this contradicts to a union a intersect c. This contradicts to a intersect c is subset of b union d. Lead to a intersect c subset of b union d. Yes, because anything in here must be in there. But now we have that x in here, but x not in there. Or we can say in another way, say x in a union c, a intersect c. A intersect c is subset of b union d. Therefore x in b union d. X in b union d is contradict to the fact that x is not in b union d. Then we can try in other way, like this, or other way. We say that since x in a intersect c, and by hypothesis a intersect c is a subset of b union d, we have x must be in b union d, and this one is contrary to this one. Contradicts to a x not in b union d, and therefore our assumption is wrong. Our assumption a is minus b and c minus d are not disjoint is wrong. Therefore they are disjoint. Thus we have the two sets are disjoint. So which is what we need to show. And that's complete this for the backward direction, and we finish the proof.